All right, welcome students to Lesson 1.2.2, Composite Functions. So in the warm-up, if you want to pause this and complete the 4 questions, first one, they want you to evaluate g of f of 2. Second one, rationalize your denominator. Third one, solve for x. So please pause this, and then when you're done, come back to check your work. Okay, welcome back. Let's take a look at this first one. We want to find g of f of 2. So that means I got to plug the 2 into the f function first. So f of 2 is equal to 2 times 2 squared plus 5. 2 squared is 4. 4 times 2 is 8. Plus 5 is 13. So now let's evaluate g of 13. So I have 3 times 13 plus 2. Well, 3 times 13 is 39 plus 2 is 41. Now to rationalize the denominator in that first, well, let's do the second one first. Let's go 3 over the square root of 5. I'm going to multiply by a giant 1. So the square root of 5 over the square root of 5. That gives me in the numerator 3 square root 5 over square root of 5 times the square root of 5. It's the square root of 25. Or 3 square root 5 over 5. I'm going to take that first rational expression and multiply by the square root of 2 over the square root of 2. That gives me 2 times the square root of 2 in the numerator over 3 times the square root of 4. Square root of 4 is 2. So 2 square root 2 over 6. Well, that reduces down to the square root of 2 over 3. Now on the last one, I want to get x by itself. So let's multiply both sides by 3x plus 2. We're trying to get rid of fractions to start with. So that gives me y times 3x plus 2 equaling x minus 5, because those cancel. Now, think of it like this. Let's get everything and get rid of our factors of y and 3x plus 2. Let's get terms on both sides, just terms, not factors. So I'm going to multiply through by y, so that's going to be 3xy plus 2y equaling x minus 5. So I've got these terms now, and 2 of them have x in them. So let's get those 2 terms onto the left side and the other 2 terms onto the right side. So I'm going to subtract an x from both sides. That gives me 3xy minus x plus 2y equaling a negative 5. And then I'm going to subtract 2y from both sides. That gives me 3xy minus x equaling a negative 2y minus 5. And factor now that we got the x terms on the left side, let's factor an x from each term. Divide by 3y minus 1, and x equals a negative 2y minus 5 over 3y minus 1. There are your warm-ups for today. Proceed to the next slide. Today's lesson is finding inverse functions. Now, keyword inverse functions. We're going to talk about inverse equations, but eventually we're going to be talking about inverse functions. So here is Sean as a factory manager. He knows on a given day employees can fill P equaling 2 times n squared minus 8 orders. So this is right out of your book. We want to find the inverse equation. recall that the inverse equation is an equation that undoes the mathematical operations on n. So if I wanted to undo my operations on n, well, n is squared, then it's multiplied by 2, and then subtract 8. So let's find the inverse equation. First, start by swapping your n's and p's. So n equals 2p squared minus 8. Now do these in reverse order and with the opposite operation. So I'm going to take n, instead of subtracting 8, I'm going to add 8. And then I'm going to, instead of multiply by 2, divide by 2. And then instead of squaring, I'm going to take the square root. And that equals p. This is the inverse. Now someone says, whoa, slow down. I didn't catch all of that. Okay, let's look at it through undoing operations. I'm going to add 8 to both sides. Plus 8, plus 8, and plus 8 equals 2p squared. Divide by 2, divide by 2. N plus 8 divided by 2 equals p squared. Now, take the square root of both sides, which technically gives us a plus or minus. So when you do this other way, we kind of miss one of the little details here. And that's our inverse equation. So over here, I really need to add and subtract the square root of n plus 8 divided by 2. These are not functions. These are just inverse equations. On to the next slide. So what makes something an inverse? Well, the main characteristic is that an inverse is swapping your x's and y's, which means if I can come up with one equation and its table, then the inverse is going to be the swapping of the x and y's and the undoing of the operations. But the tables are also just swapping x and y's. So let's take a closer look at this. If you go to your calculator and type in f of x. Now for f of x, I'm going to use a flashy, bright color. Let's say f of x is equal to x squared, x minus 2 cubed plus 5. You type it in, and you look for the values. Negative 4 plugged in gives you a negative 211. Negative 3 plugged in gives you a negative 120. Negative 2 is a negative 59. This is a negative 22. Then we got negative 3, 4, 5, 6, and 13. You now take some time to find the inverse. So let's see. I'm going to start by, I got subtract 2, cube, add 5. So then my inverse, we use this for notation, f of negative 1 of x equals, I'm going to take x, I'm going to subtract 5. Then I need to do the inverse of cubing. So I'm going to take the cube root of that. And then I'm going to do the inverse of subtracting 2. I'm going to add 2. So there's my equation. Now I'm going to take and build a, oh wait, I don't have to build a table. Because what we have is just the swapping of x and y. Switch x and y, because in order to go from f of x to the inverse, we switch x and y. So negative 211, negative 120, negative 59, negative 22. Ooh, I want to use purple. Now let's graph these. Let's graph f of x. Now I'm going to start with 0, -3. These other points I don't think are really going to be on a graph that goes from a -10 to 10. So 0, -3. 1, 4, 2, 5, 3, 6, 4, 13, that's 10, 11, 12, 13. Looks like we have ourselves a little bit of an S curve here. Remember, we're swapping X's and Y's. So I'm going to draw in this special line. This line is y equaling x. In other words, we're swapping our X's and Y's. That's reflecting. That's the same as reflecting over y equaling x. So if I plot these points in purple for the inverse function, I should get something that is a mirror image or a reflection over the line y equaling x. So let's plot these same points. -3, 0. 4, 1. 5, 2. 6, 3. 13. There's 11, 12, 13, 4. And so my graph looks something like this. And it does look like a reflection over the line y equaling x. So f of x and f of a -1 of x inverses are reflections over y equaling x. Go on to the next slide. Now, what I want you to do is to find the table for the inverse function and the graph for the inverse function. You have g of x. Here's the table for g of x. There's the graph for g of x. Find the inverse table and inverse graph. Do not find the equations, or do not write equations. So pause this now and come back when you're done. Okay, welcome back. And here is what we are looking at for our new table. Swap your x's and y's, -6, 0, 2, 1.5, 0, -1, 0, 4.5, and a -2, -1, 0, 1, 2, 3, 4, and 5. Now let's plot those points. -6, -2. 0, -1, 2, 0, 1.5, oops, sorry, 1, 0, 2, -1, 3, 4.04 and 4.55. So here we go. I'm going to give this my best shot. The graph kind of looks like this. And if we draw our line y equaling x, they look like reflections over the line y equaling x. Now, a couple things to notice. Points that are on the line are on both graphs. This 0.55 happens to be on both the line y equaling x and our inverse function and function. The 0.11 and the point -1 are on both graphs because that's where y equals x. On to the next slide. So, when Ty computes the inverse of f of x equaling 3 times x minus 4 squared, he gets f to the -1 of x equaling 4 plus the square root of x divided by 3. Is Ty's equation correct? Explain. Yes, it is the correct equation, but it's not the inverse function. So let's try to come up and look at the difference between an equation and a function. Remember, a function must pass the vertical line test. I period, E period, that is for each x in the domain there can be only one y in the range. So if we take a look at the graph for f of x, it's going to look something like this. Now, if we graph the reflection of that over the line y equaling x, let's call that x, y, x, and y. It's going to look like this. This point right there is a -4, 0. The pink f of x is a function. The inverse f of -1 of x is not a function. This does not pass a vertical line test. For this x value, x sub 1, there is a y sub 1 and a y sub 2. So we have to go back to the original equation and restrict the domain. So f of x equaling 3 times x minus 4 squared has to be redefined for only x being greater than or equal to 0. And we lose the left half. Well, then what do we end up keeping over here? Do we keep the top half or the bottom half? So for f of a negative 1 of x, which is equal to 4 plus or minus, well, we're just keeping the plus, because I'm keeping the positive part of f of x, everything greater than 0. So now, this will pass the vertical line test because we've gotten rid of the bottom half. And that's how you can restrict your domain. On to the next slide. Last concept, we want to verify if two functions are inverses. So if you think about it like this, it's a little bit abstract, but if one undoes the other, then if I stick one function into the other function, I should get x out. So if I start with x and I add 4 to it for one function, and then I have to undo adding 4, well, inverses undo all the operations that f of x, or the original function, does to x. Therefore, if I put f and g of x together and I get x, then they must be inverses. So let's give this a try. Let's see if this f of x and g of x happen to be inverse functions. So we're going to find f of g. I should switch those colors around. We take f of g of x by taking the g of x function and plugging it into the f of x function. So I have 3 times my g of x function squared minus 4. This is x times the square root of 3 plus 4. So let's take that, what's inside the parentheses, and square it. So using our squares or rectangles, I have x times the square root of 3 plus 4, x times the square root of 3 plus 4. Multiplying all this together, that's 16. This is 4, x square root 3, 4x square root 3, and this becomes x squared, and the square root of 3 times the square root of 3 is the square root of 9, or 3. So I have 3 times 3x squared plus 8x times the square root of 3 plus 16 minus 4. So now I'm going to distribute my 3. I have 9x squared plus 24x times the square root of 3 plus 48 minus 4. This is not looking like x. That does not come out to be x. So I'm also guessing that g of f of x will not also. So f of g of x does not equal x, and you can verify the other one, nor does g of f of x. on to the next slide. There we go. So now with f of g of x, let's give that a try. So we've got f of g of x, and f is the square root plus 2. G of x is x squared minus 4x plus 4. This looks kind of messy, but actually this factors into x minus 2 times x minus 2, or x minus 2 squared. So I'm going to take the square root of x minus 2 squared plus 2. Those undo each other. I get x minus 2 plus 2. Hey, I got x here. So f of g of x equals x. So I'm going to guess g of f of x is, but let's just verify that. I'm going to do this all in black because I'm so excited I don't want to be switching colors. So g of f of x, so that means I got the square root of x plus 2 squared minus 4 times the square root of x plus 2 plus 4. Using our squares for multiplying, I got the square root of x plus 2 square root of x plus 2. That's the square root of x squared, or just x. This is 2 square root x, 2 square root x, and that's 4. So I have x plus 4 square root x plus 4. I'm going to distribute here. Minus 4 square root x minus 8 plus 4. Let's see here. Well, those add to 0. 4 plus 4 is 8. Minus 8 is 0. And I'm just left with x. So f of g of x equals x, and g of f of x equals x. So g of x and f of x are inverses. Now what I'd like you to do is to see if you can show that these two functions are or are not inverses. So pause this, and when you're done, come back and check your work. Okay, welcome back. You can kind of take a look at the work here. Both of them come out to be 1 over x to the 9th. So they are equal to each other, but they do not equal x. Therefore, these are not inverses. Hopefully you enjoyed this video. Please tune in tomorrow for another excellent adventure in pre-calc. We'll talk to you later. Bye-bye.